This video is about SQL Server Profiler. And of course, if you do not use SQL Server, then this video is completely irrelevant for you. Sorry about that. If you do use SQL Server and you don't know Profiler and you also don't know extended events, then this is probably a must-watch for you. Hi, I'm Philip from codekabinett.com, and as I said, today I'm going to talk about SQL Server Profiler. This is a tool that too many Access developers don't know. But if you are not an Access developer but are working with .NET and use an ORM mapper like Entity Framework or NHibernate, this video is probably of equal interest to you because you're dealing with the same problem there. So SQL Server Profiler is a tool that kind of profiles or visualizes all the SQL statements that are sent to SQL Server. And that is extremely helpful if you use some tool like an ORM mapper or Microsoft Access that kind of translate the SQL for you or generate the SQL for you. So you don't send or you don't write the actual SQL that is sent to SQL Server. And if you are an Access developer, you might be slightly shocked if I tell you you write SQL in Access and maybe something entirely different is sent to SQL Server if you use ODBC to connect to SQL Server. So, but before we go into more details, I already mentioned extended events. And if you kind of heard about Profiler and Googled it, and you will most likely found some articles, texts or videos that tell you don't use Profiler, use extended events. And there is quite a bit of truth in that. Extended events are the more modern way to trace and profile SQL statements. And for most purposes, I actually would recommend using extended events because they have less overhead. They do not slow down the server so much because kind of logging and profiling all those SQL statements that are sent to the server has quite a bit of overhead. So if you do that on a production server and let it run for a longer period of time, absolutely use extended events. And also if you need more modern, like events that have been added to recent versions of SQL Server, you also need to use extended events because SQL Server Profiler is basically deprecated. It's included in every version of SQL Server. It still works and it's still like in maintenance, but it's not really updated with any new stuff. It's basically I'm not sure if there were relevant changes since SQL Server 2008 or so, or maybe even earlier. So it's not really bleeding edge technology, quite the contrary. But still, there is one use case where I absolutely prefer to use Profiler, and that is actually the use case where I use like SQL profiling the most. And that's the reason why I would like to show it to you and introduce you to this tool. So, yeah, and the basic reason why I rather use it is because it's really to set up, really easy to set up for that purpose, and it's sufficient. It does what the situation requires, and it's more user-friendly to me. The UI shows the stuff that I want to know at that moment. Okay, that being said, let's over. And this is the Northwind database basically. I moved it using SSMA, I moved it to SQL Server, and all the tables are linked via ODBC to the Northwind database. And obviously I'm not really familiar with ORM mappers, so I'm going to do all examples in Access, but the basic core problem is the same if you work with VB.NET and use an ORM mapper. So bear with me here and try to abstract that away if that is your field of work. But if you're working with Access, then you're right familiar with all this stuff. So the tables are linked with ODBC to a remote server on the local network. So it's pretty fast. I can query that stuff. I can scroll here. It's basically all it's instant. So everything's fine, isn't it? Like we've got a couple of queries, and I didn't really modify the queries. They are just as they were in the Northwind sample. And let's look at the invoice data query. That comes up pretty quickly. All fine here. I can scroll really great here. Now I want to create a new query, and I get rid of this stuff, and now I drag in the invoice data query, and I want to see all columns, but I want to see invoice data only for some products, like where product ID is between 70 and 77. And now let's run this, and this is looking less good than before. And well, it's running and Access is not responding. And actually, I know that Access will not respond for quite a while. So I kill Access off, say close the program. And now let's turn to Profiler. So, and as you see, this is a Profiler from the SQL Server 2016, but it does not matter at all as it's not changing at all at the moment. So if you start it up, you've got a gray screen with nothing in it. And the most important things are the toolbar buttons up here. And what you want to use is basically, excuse me, I get confused, it's the new button. And we'll look at the other buttons in a while. So we connect to SQL Server. And I'm not one of the persons who always work as SA, as a system administrator. I usually do not do that at all, and I recommend you don't either. But that's a bit of a gotcha here, and another disadvantage of Profiler. If you want to run Profiler, you need to have system administrator permission on SQL Server. And you will see in a second why that is the case. So let's connect here, and we get this dialog. And you can use that to basically select a template, but the standard one is good enough. And we will go back to this dialog in a second, but I just run this. And now you see there are already existing connections here. And this is probably what you're seeing when you're connecting to either a production server or to a shared development server. There's a lot of stuff going on here already. And that is quite a nuisance because you've got a lot of noise. And we didn't even start our Access application, but we quickly can do that. And because I terminated it, it asks me, so this connects, and we can say login, and it's doing stuff, and we switch over to Profiler. And now let's pause this. And we are not looking for the actual SQL stuff. And you see, this is Microsoft. Let's zoom in a little bit, or rather with the active zoom. The application name is Microsoft Office. That's pretty obvious. And the login I use is Northwind user, and that is what I am interested in right now. And you see there's a lot of stuff in here with a different user. And if we go up here, there's another user doing stuff here that is running on a different computer in a loop to generate the noise you would normally see if you connect to any server that's used by someone else at the same time. And you might even see that if you have SQL Server Management Studio just open on your computer connected to the same server. You will also see all sorts of commands going on there. So this is quite realistic, even if it's just your local server used by no one else. And to filter down this noise, we need to go back to the properties. And before we do that, let's quickly look at the buttons here again. We've got, these are the most important buttons here, these ones, and this one. We're going, and this is basically play to start the stuff, pause to pause it, and stop to stop your trace. And the eraser thingy on the left is to clear everything that's in here. And finally, this one is the typical properties icon, and that's what we are going to need now. But before we can use the properties really, they would be read-only now. Before we can change properties, we need to stop the trace. And now we can use the clear button to get rid of all that stuff. And now this is the same dialog you saw at the beginning. And the important part is in the event selection tab. And you can select lots of additional events. If I click on the show all events button here, you see there are lots and lots of events in here, and you can expand them, and they're grouped, and there's lots and lots of stuff in there. But usually you don't need that for the purpose of looking at SQL statements that are sent to the server. And that's what we are going to focus on today. So I'm going to break out of my stuff here. So sorry about that. And I hit escape, so the dialog closed. So here we are again, and I'm not going to use show all events, and there are also lots of other columns here, and you usually don't need them either, so I leave that. But what is really important is the column filters dialog. And you got a couple of different stuff in here to filter, basically columns. And the most useful is usually to filter the noise down is the login name or the NT username. So I'm going for Northwind here, and it's a like operator, so I have to use the % at the end, or I wouldn't need to write the full name, but I'm lazy. So I just enter that to filter it down and hit OK, and say once again run. And now this looks much more like I want to see it, but that's important if you work with Access, and I believe it's the same with most ORM mappers. Microsoft Access uses multiple connections, and it opens additional connections whenever it feels like it, or rather when it thinks it needs another connection. And I think some ORM mappers are doing the same, that they're using multiple connections at the same time. So you cannot just filter on one spit, on one process ID on SQL Server, but you need to filter about the username or the application name or maybe the local client name. But for our purpose here, the username is just fine. You see all the noise is basically gone. So these are existing connections, and we're not really interested in these, so I clear that, but the trace is still running. And now we go over to Access, we close this, and go back to our invoice data query and open that in design view. And you see this is a query involving 6 different tables, or rather 5 tables and 1 other query, but that's not really the matter here. So you would expect to see a SQL statement pretty similar to this nasty beast here. And the important part, you don't need to really read it, but the important part is that all 6 tables are listed here in the from clause, and you would expect the SQL that is executed to SQL Server or sent to SQL Server for execution, you would expect that to be roughly the same. But it isn't. So we clear this once again, and now we run this query. And now let's hit pause here and go over to SQL Server. And you see, it's not like SQL Server got 1 SQL statement, but it got a lot. And you see it down here, 274 rows, a lot. So, but let's go up to the top, and there you see the statement, and that is basically the main statement here. And I know it's hard to read, so let's copy that to like something like Notepad to better visualize it, and you switch to SQL language quickly. Now the important part to look at is the from clause here. And you might be shocked. There are only 1, 2 tables here. Not 5, not 6 as in Access, only 2. So let's go back to Profiler to look what's happened here. So this is on the orders table and the shippers table. And now the next statement is another statement on the employees table here. Then there is another statement on order details, and yet another statement on customers, and one more on products. And if we go to our Access database and just go back to the design view, you see orders and shippers. These are the 2 tables that we had here initially, orders and shippers. These were joined in one statement on the server, and then the other tables here, the customers, the employees, products, and order details, these were all added later in separate queries. And that is quite shocking because it's not a single SQL, but multiple statements. If we go back to SQL Profiler and look at the statements, let's look at this one. And the important bit is this here, the where condition. It's basically doing a key lookup here. And from the database perspective of the jet engine who received our query and translated it to this mess, it's not really that bad to do that, because there is a chance that SQL Server would have processed the query in the same way. It would have just gone to the core tables, grabbed all the records, and then doing key lookups for all the other tables to fetch the records from those tables. It's possibly that SQL Server would have done it the same. So the basic idea the jet engine had here to translate it to these queries wasn't too bad. But the problem is, if SQL Server does it, or the jet engine with a local Access database, then this is a decent approach. It might not be the best, but we don't know that. It's reasonable to work that way. But if you send all the key lookups over the network to fetch the data, that is going to be a bit of a problem. And this is on a local network already. If you move to the cloud and put your database in Azure SQL or any other SQL server on the cloud and have latency between your local client and the remote SQL server over the internet, then this is going to kill performance even more than it did already here. So, and it's all the same with the other queries that are key lookups, and they are not ideal. So, but look further down here. Now, this is also, we didn't do anything else than run the single query. It's all the Microsoft Office application with the Northwind user. And you see these SP execute statements, and you are going to see that a lot if you're using ODBC to connect to SQL Server with Access. And the thing is, you need to look at these statements to figure out what it's a prepared statement. And the first value here, like here, the 3 or the 1 up here, we got another one. This is the ID of the statement. And if you want to find out what Access sent to the server, you need to go up, all the way up, to find a matching prep exec. And that is actually what we were looking at the beginning here. So, and this is the important bit here. We've got a parameter P1 and it's equal 3. And then the prep exec is called, it's preparing a statement, and the bit at the back is the statement, the select stuff over here, and it's passing in the P1 as the statement identifier, and that is the value 3. So whenever you see the 3 down here, like this statement, the first value is the 3. So it's statement 3 from up here. I really need to practice a little bit with the zooming stuff in here. So you know, this statement is basically a select ID from employees table. So, or rather, no, I made it wrong. Because the basic explanation was correct, but here is another prep exec statement in between reusing the statement ID 3. So this is rather a select ID from company, but the basic stuff remains here. You need to go up. Like if you see the 3 here, you need to move up to the next prep exec that uses the 3 for an ID. And then you see what that statement actually is. It's a little bit complicated, but it actually makes sense performance-wise to kind of prepare a statement, like compile it, and then only reference that prepared statement. That improves performance quite a lot. And if you look at this, there are lots and lots and lots of statements in here that Access is sending to the server. And that is obviously not really ideal to do here. And it's getting worse. That was the initial execution of the query. And now, actually here, Access is starting to really fetch data. And then it's usually doing in batches of 10 rows. So it's first executing the query, getting the ID values it needs, and then it's fetching the actual rows. There's a lot of interaction and a lot of chattiness between SQL Server and Access, or rather Access and SQL Server, because it's Access initiating all that stuff. And I'm not going into more detail how you can influence that. And there's not too much you can do about it, but a little. But that would go totally beyond that. And I guess you will see similar stuff, maybe not as bad, but similar stuff when you use an ORM mapper like Entity Framework. So what would be an approach to rein in this problem? Well, the problem is that Access just kind of splits this query into multiple pieces and kind of sends off all sorts of SQL statements to the server. And the core method to prevent that is to either use a path-through query where you send SQL directly to SQL Server, and then the local jet engine, the Access ACE engine, will not mingle with your SQL. It will get straight to the SQL Server. But the drawback is path-through queries are read-only. So what I usually do is kind of prepare these statements, these SQL select queries with multiple tables, and I create a view. And I'm not going to show it, but I prepared a view invoice data, and that is basically this query on SQL Server. And it also takes a little bit of time, but if we go back to our original performance problem and we create a new query and now pull in the invoice data view, which resides on SQL Server and is linked to the local database, and do the same as before, like adding the star, going down to product ID and say it should be between 70 and 77, and make a guess how long it will take now. Not long. And you see only 3 rows were returned by that query. And just to show the sheer horror, let's do it again with the original query. Create a new query, put in the invoice data here, put in the star here, product ID between 70 and 77. Before we execute that, we switch over to Profiler and just clear that and start the profiling again. And now we run this. And now you see on the left-hand side, maybe we make this wider. It's not responding. Of course, it's not responding to stuff, to drawing the window. But you see, it's running. It's still running, and we are at 35,000 rows in Profiler. That's 35,000 queries sent to SQL Server. We're by 45,000 now. And I do not know how long it will take. Of course, this Northwind database is a little bit bigger than the plain sample you can download. There are 1 million rows or 1.5 million rows in the orders table and more in the order details and stuff. So it's a pretty big query that is running here and pretty big data. But you now see, for this particular query, it's absolute disaster what the ACE engine did to the query with all the key lookups, because to find the 3 rows that we are actually looking for, it has to fetch First, the 1.5 million orders, then it has to do the key lookups for the detail rows to get to the product and to compare the product ID, or at least to the order details. And you see it's at 110,000 rows now. And yeah, that is basically completely insane here. And just for the sake of it, let's compare that. Let's pause this here, and yeah, I need to kill off access because it's not going to respond at all for a while. But just for the sake of it, I should have shown that earlier. Let's compare that to the approach with a view. So we are logged in, we create a new query, we just pull in this thingy here and do once more the query for product ID between 70 and 77 and make sure we run Profiler. I clear everything. It's still running, and now I run the new query and it's done. Pause it. You see it has sent over one query down here on my view invoice data, and it's just one query. There are two rows because one is batch starting and one is batch completing. So I wasn't exactly correct. As I said, there were like 110,000 queries sent to the server because it was only significantly less, like half of that, because we get here one row for starting a query and one for completing a query. But nevertheless, it's an insane amount of stuff here. But nevertheless, Access still is using these key lookups to fetch the values. That it's still doing here. But the original query is now really down to one single SQL statement because Jet Engine doesn't need to split that up anymore. Yeah, so I think that could have been a shocking revelation to you if you have never done that before. And that is something that is really, really helpful to know if you run into performance issues with SQL Server backends, that you actually have a tool to look behind the scenes and actually see what Access is doing with SQL Server. And that is, if you are developing something, you write a query in Access against the SQL Server backend and you hit execute in the query and you see it's blocking everything. Or even if you are one level above in the UI and you create a form and you worked on the form and think, yeah, it looks nice now, and then you open it in normal form view that all the queries are executed for the form record source and the row sources of the drop downs or list boxes and maybe the subforms you might have in there, and then everything freezes and Access doesn't do anything, or it's taking much longer than you expected, and you would normally be totally lost what's causing the problem and would need to kind of switch around SQL statements and trial and error to find the problem. But with a tool like Profiler that you can just fire up, just start, maybe enter a filter to your username to get rid of any noise that's in there additionally. But in a couple of clicks, you can look behind the scenes. And that is where I always, at the moment at least, I always would prefer Profiler over extended events, because the user interface for extended events is not as straightforward. It's not, well, I'm not going into any more details of extended events. But just keep in mind, I'm not saying Profiler is better than extended events, because it's not the case. But for this particular purpose, on hitting a button to look behind the scenes and what's going on in SQL Server on your development machine right now, Profiler is still the better tool for this purpose. So, okay, I think that's it for today. Thank you very much for watching. I hope you enjoyed the video, and I'll see you next time.